Hey, what's going on, students? This is a diagram taken from PhET, which is an educational resource from the University of Colorado. It's a free service, so you can use this as well. The link will be in the description below. So this is going to talk about circuit construction kits using DC power or battery powered. So I have created 3 series circuits here using batteries, wires, and light bulbs. And the first diagram here in the upper left-hand corner has 1 light bulb hooked up to the circuit. The next one has 2 light bulbs hooked up to the circuit. And the third diagram in the bottom center has 4 light bulbs hooked up inside of a series circuit. So we know that since it's a series circuit, that there's only one path for the electrons to flow. With that being said, when we look at the light bulbs, look at the amount of brightness coming off of it. And the brightness can be determined by looking at the yellow lines coming from the light bulb. That's to represent light. You can see the length of these here in the series circuit with only 1 light bulb is the longest of the 3 diagrams. So here where I have 2 light bulbs, they are a little bit shorter. And on the third one at the bottom, you can clearly see that the light emitted is not nearly as high. So what I'm going to do is I'm going to grab this voltmeter. And the voltmeter is going to tell us the voltage of the battery as well as the light bulb. So when I look at a simple series circuit, these batteries are 9 volts. And when I take them down to get the reading from the actual light bulb itself, you can see that it is indeed 9 volts. So all of the electrons are going from the negative end of the battery, because electrons are negatively charged, and they're going through the light bulb, and that light bulb is able to use all 9 volts that are traveling through the circuit. So we'll come over to diagram 2, and we'll see again the battery is 9 volts, but we have 2 light bulbs. So when I connect to this light bulb here, my voltage going through that light bulb is only 4.5 volts. That bulb cannot use all 9 volts of electricity, which is why it is glowing a little bit more dimmer. If I come to the second one, it is also getting 4.5 volts of electricity, and that is causing the delay and the less amount of light that's being emitted from the 2 light bulbs. So think for yourself and predict, if I went from 9 volts to having 9 volts in this light bulb, and I went from having 9 volts in the battery to now having only 4.5, what mathematical operation am I using here in order to determine the amount of voltage per light bulb? So the electrons are getting divided up equally between the light bulbs in the series circuit. So it's basic division of 9 volts divided by 2 light bulbs, which gives me 4.5 volts if I was using a calculator, or if you can do the simple math in your head. So take a moment to predict. I have this battery here, which is 9 volts. If I have 4 light bulbs, how much voltage do you think each one of these light bulbs is able to use? If you said 2.25 volts, you are correct. Because again, my 9 volts here are getting divided up amongst the 4 light bulbs in the series circuit, which means that only each light bulb is getting 2.25 volts. Now, in real life, not simulation, there's a good chance that these light bulbs wouldn't even light up at all because there's not enough voltage to power them if they are designed for 9 volts of electricity. So we have all seen different thicknesses of wires, right? There's a big difference between the thickness of a wire on a telephone pole and the thickness of a wire to an iPhone charger. The iPhone charger would not be capable of handling the amount of voltage going through a telephone pole or the main electrical grid. So if you were to go into your house or your apartment and find the fuse box to your house, you will see large wires coming out from that. That is because there is tons of electrons and electricity flowing from the fuse box out to your house. Each one of those cables powers, a family room, the dishwasher, the kitchen, the bathroom 1, bathroom 2, and each individual bedroom is on its own breaker. So, if you tried to use an iPhone wire instead of one of those thick cables, which has about the circumference of a dime, it wouldn't be capable of handling the power, and it would ultimately catch on fire or melt. Probably melt over fire. But, so in the diagram, I can still see that I have a 9-volt battery. And if I use a tiny wire, right? Oh, let's move it back to tiny. If I have a tiny wire, the voltage on the battery is 9 volts. If I make that very, very restrictive through the wires, it's still a 9-volt battery. So what I want to do is I want to go back to tiny. And you'll remember from looking at this that this circuit having 4 light bulbs, each bulb was using 2.25 volts. Watch what happens to the voltage on the voltage meter when I make the wires skinnier and more restrictive. You can see that now this light bulb is only getting 1.84 volts because the wires are so thin that it's not allowing the electrons to move at the speed that they were before. So when I look at my diagram with only 1 light bulb up here, we had said that it's getting 9 volts. Watch what happens to the brightness of the bulb and the way that the electrons move through the circuit. It's moving incredibly slow. Let's give it less resistance. The bulb gets brighter and the electrons are moving much faster. So now that we're back to our diagram, I am going to hook up this amp meter to my circuit. And again, we have the 9-volt battery and 1 light bulb. So if I put this on here, it's going to measure the amount of amps going through the circuit. So for the circuit number 1, 1 battery, 1 light bulb, I have 0.9 amps. If I go to a battery with 2 light bulbs, I am down to 0.45 amps. Now again, if we do simple math, we can see that having the 2 light bulbs is creating enough resistance that it's slowing down the electrons by half. So I will come down here and I will hook it up to our circuit with 4 light bulbs, and I can see that it is at only 0.22 amps. Now the other thing that's nice about this diagram here is that I can see how fast the electrons are moving. And I can see that they're slowing down here in diagram 2. And I can see that they're moving incredibly slow in diagram 3. And my amperage meter is going to show how fast those electrons are moving. So here's a fun question for you. We want to know if the thickness of the wire and the resistance of the wire is going to change the amperage as well. So take a minute and think about that. All right, so let's go ahead and test this logic here. I've got my amp meter hooked up, and as I increase the resistance of the wires, the amperage does indeed drop. So for this first diagram here, I went from 0.9 to 0.58. And when I come over here, diagram 2 was at 0.45 amps. And now has dropped all the way down to 0.32. Now, some of you might be thinking, well, does it affect the amperage on the other light bulb? Let's take a look. It most certainly does. So we'll go back to diagram 3, where it was at 0.22 amps prior, and now it is dropping down to 0.18 amps. And that applies for each of the light bulbs in the series circuit. Hey, what's going on, students and fellow educators? It's me, Mr. Spoony, again. And I know being back on online instruction isn't where we want to be. However, it's what we're dealing with right now with COVID-19. And I know that cyberbullying is a thing. It's happening in the schools, and it's happening with online learning as well. And I just wanted to take a moment to say that people in your life who just want to put you down or make you feel like you're less relevant aren't worth the emotion. And I know it's tough. I recently was dealt a situation where somebody wasn't treating me fairly. And I can tell you this, even as an adult, you still are going to have, the haters out there. So be true to yourself. Be who you are every day. Be awesome. Take care of yourself, take care of your family, and take care of the people who truly care about you and the people who value you for who you are, not what they want you to be. So be a warrior. Repping the warrior hoodie today. You know it. But take care of one another. The people who want to put you down, don't even listen to them because they weren't worth it in the first place. I love you all. Stay safe. Wear your mask. And we'll see you later. Thanks.
The 2015 Cup Series champion.
If it wasn't for lap traffic, it wouldn't even have been a race. I don't know what y'all are whining about, but if you don't like that kind of racing, don't even watch.